This video will cover getting PCs hooked up to the IP phones and then getting the VLANs needed to make that work. Now this has been a very basic configuration so far. The phones are just running on VLAN 1 tied back to the router here. I can show you a couple things to set the stage of what we're looking at. So if I take phone 0 and phone 1 up here, we can see that they have the same dialing prefixes, just a 4-digit number starting with 1. So if I dial 1337 over here, pick it up, we should see it's ringing on the other side. Now some of the problems that we're going to have with this though, is that we don't currently have the ability to attach a PC to these phones and have them communicate. So it's one really common thing that you see in business networks is that there might only be one cable ran to a cubicle or an office, and that cable goes to the phone. We need the phone to connect into the laptops, and then those laptops can get internet service as well. So what I'm going to do is just drag out two laptops here, go ahead and put them to DHCP. So we'll set this up for them to be connected a little bit later on, and we're going to work on configuring some things. Number one, let's start with the switch. The switch has a pretty basic configuration, and if I do a show run for you, you'll see a few things in here. Fast Ethernet 1, the connection back to the router, is currently an access mode port on the voice VLAN 1, as are the next few interfaces, 2 through 5. Now we're going to need to change that around a little bit because the voice traffic will only be on a separate VLAN from the data traffic. So we're going to work on that part first. Let's get into config T and make a couple of VLANs for voice and data. I'm going to make let's do VLAN 10, call this voice, and we'll do VLAN 11, and we'll call this data. The reason we are doing 10 and 11, I can show you here in a second, is that the IP address scheme that's already been chosen for this particular network just happens to use the .10 subnet for phones, so we're trying to keep that pretty consistent. I'll show you here on the router. If I do show a run here, we can see the DHCP pool for voice has already been configured for 10, so to try to keep this simple, I chose VLAN 10 for the voice. So back over to the switch. On the switch, I have VLANs 10 and 11 created, and so we need to tell the switch to actually use them. Now for the switch to carry two separate VLANs back to the router, the interface between the router and the switch needs to be a trunk port. We're going to end up setting up router on a stick here. So if we go to my interface fast Ethernet 01, we're going to do a switch port mode trunk, and then we're also going to remove the voice VLAN. So we'll say no switch port voice VLAN 1. So just cleaning up that interface. We'll go back and look at the running config here in a second. Now I want my other three interfaces or four interfaces that we had configured, 2 through 5, to support the voice VLAN and the data VLAN together. I'm going to get into the interface range, so we'll do interface range, fast Ethernet 02 through 5. This could be very well be the rest of the switch, but we only used these ports here, so we'll do 2 through 5. I'm going to do a switch port, mode access, switch port access VLAN. Let's do 11 for data. Switch port voice VLAN will be 10. Now the other thing I know is that my users should never be plugging in a switch to this network. So to make their phones boot up a little quicker, get their PCs and address faster, I'm going to turn off spanning tree. You might also want to consider turning on BPDU guards if you're going to do this, but for this example, we'll just do spanning tree port fast. So just turning off spanning tree. And there you can see the message saying, right, if we connect a switch or a bridge or something else, we might have a switching loop. I'm going to end this configuration, do a show run, and just walk you through what we just set up there. Really all of the work happened with these interfaces. The interface between the switch and the router is now a trunk. The switches will use VLAN 11 for data, so that's what the PCs will be using, and they'll be using 10 for voice, and we turned off spanning tree for those. Down near the bottom, or if we do a show VLAN, we can see we've got VLANs 10 and VLANs 11 for data and voice. Next thing we need to do is go to the router and we'll fix a few things here. We'll start off by just looking at the basic configuration of this router. So if we do show run, we'll see a few things here. Presently, I have a single pool for DHCP for the voice traffic. I'll create a second DHCP pool for the data traffic as well. Moving on farther down the line, Fast Ethernet 0 is what connects to the switch, so that's that trunk interface between those. I'll have to remove the IP address from the physical interface and create two sub-interfaces, one for each VLAN. These two sub-interfaces will be comprised of that router on a stick setup. So we'll set the encapsulation, set the IP addresses, and everything there. The telephony service can stay the same, so that's still on the correct voice subnet. And our phones here that have already been registered, if we just reboot them, they'll come back and be registered correctly. So starting off here, we're going to start with that DHCP pool for voice traffic. So we're going to go IP DHCP pool, and we'll call this data. Let's set the network for this pool to be, let's do 11.0, and we'll just call this a slant 24 as well. The reason I chose 11, let's just match that data VLAN that we did. Makes things a little bit easier to look at. Default router will then be 11.1, which we haven't configured yet, but we'll get to that. And we still need to set the option of 150, that's telling the phones and devices where the TFTP server is, to 11.1. Okay, so we're going to exit out of this. We're going to exclude our own IP address from the DHCP pool. So we'll do an IP DHCP excluded address of 11.1. So just a normal DHCP pool. If I show the running config from that, do show run. So this DHCP pool is almost identical to what we've had set up in the past, just using the 11s instead of 10s. So here's our new pool that we just created. Next thing that we had to fix, getting rid of this physical IP address, or the IP address on the physical interface, and setting up router on a stick. Let's go to that interface, Fast Ethernet 00. We'll just do this first, no IP address. We have to create our sub interfaces. So we'll do interface Fast Ethernet 00.10. Again, I like to make that match my VLANs, matches the subnet. Super simple to keep that stuff consistent. Now to do this, I need to tell it what encapsulation to use. We're going to say use .1q encapsulation and look for VLAN 10. So anytime this router sees a packet tagged with VLAN 10, it's going to pass it to this sub interface. Last thing there is just setting the IP address. Perfect. Let's move on to our second subinterface to complete the router on a stick setup. So we're going to go into Fast Ethernet 00.11, set our encapsulation of .1q. This will be looking for anything tagged with VLAN 11. Set the IP address, 11.1, the slant 24, and we should be good. Let's go take a quick look at what this looks like. In our running config here, there's our DHCP pool. We can see there's no longer a IP address on the physical interface, and we now have these two sub interfaces, both respecting the 10 and 11 VLANs. That should be really all we needed set up. Let's go ahead and plug in those laptops here and see, does this all work? So if I grab a laptop Ethernet cable, we go Fast Ethernet to the PC port on the phone. Same thing up on top here. Okay, we'll fast forward time a little bit. Now let's test our phone calls, make sure we haven't broken the phone system from working here. So let's do this here. We'll go back to the GUI. Let's make our same test call that we started with. And we're getting a busy signal for right now. Let's see. Let's try it, go in this direction here. There we go. So might have just taken a minute here for this to come up, but anyways, that phone call is ringing through both directions. If we look at our laptops here, we want to see they did get IP addresses, so that's good. They're on the correct subnet. This one has an IP address here as well on the correct subnet. Let's just make sure they can talk, and that'll complete our configuration. And we see that there, they're pinging across. So perfect. So what we've done is we set up router on a stick here to allow us to have multiple VLANs on the switch. The multiple VLANs are the only way we can have both voice data and normal traffic data coming across on the switch ports. So that allowed all of our devices to be connected. The laptops still have connectivity to the router, the phones can make their calls, and everything is good so far.